Welcome back. This is an Aleks training video on predicting precipitation. The best way that I know to teach precipitation is with the picture of the swimming pool. Anything that's in the pool is soluble. Anything that's outside of the pool is insoluble. And there are anions that are soluble with some exceptions. So many things would be soluble and then certain things are not soluble. So it's actually pretty simple when you can have that visual thing, because otherwise learning it is long tables of these are soluble, these are not soluble, which ones are, which ones aren't. Very, very hard to learn, I think. So all of the ones that they're giving in solution A is soluble. That's why it makes it a solution. Otherwise it would be powder at the bottom of some liquid. So these are soluble, all these are going to be soluble, all these are going to be soluble, and they're going to mix them two together. You're then asked, is there a precipitate that forms? So if you have an insoluble compound that mixes, so remember there's two parts to each one of these, potassium and sulfide. So okay, potassium and sulfide, that's soluble. Lead and nitrate, okay, so you have nitrate atoms and lead atoms, potassium atoms and sulfide ions. When you put them in the water, when you put this is going to be just NO3 negative, lead positive, right? Because it's a solution, so it's already dissociated. It's all broken apart. In that water, you've got potassium ions, you've got sulfide ions floating around. In this water, you have lead ions, nitrate ions floating around. It's not insoluble, so you don't have a powder at the bottom. When you mix them, though, sometimes they're just all going to be aqueous and nothing happens. It just is clear liquid mixed with clear liquid, and you end up with clear liquid at the end. No big deal. Nothing happens. No reaction. But in some cases, something's not going to be soluble, and it falls out of solution, and that's what they're asking. Does a precipitate form when you put A and B together? So I can't teach this. This is only, do you know the swimming pool? Okay. So this is potassium. This is the alkali metals. All alkali metals are soluble, including sulfides. Here's nitrates. All nitrates, that's the heart attack guy. All nitrates are soluble. So what happens if this positive joins with this negative, or this positive joins with this negative? Let's do this one first. This positive joining with this negative, well, all group 1 elements are soluble and all nitrates are soluble. So nothing would happen. Okay, if those two bumped into each other, nothing would happen at all. There's no real attraction. Okay, they would not come out and fall out as a solution, as a precipitate. What about lead and sulfur? Well, sulfides normally are insoluble. That's the stinky egg, the rotten egg at the outside of the pool. The only exceptions are the ones that are soluble. So ammonium, the wet diaper, if ammonium goes with sulfide, it's soluble. If group 1 elements are with sulfide, it's soluble. Anything else is insoluble. So lead with sulfide is going to be insoluble. That means it makes a precipitate. Okay, there's going to be a precipitate there. What about, what would it be called? Okay, so if you're going to have lead and sulfur, okay, well, sulfur is -2. It's in group 2, and this is lead 2. So this is 2 plus, right? Lead 2 is 2 plus, and sulfur is in group 6, so it's -2. So it's a 2 to 2. So there's no subscripts, and this would be lead sulfide. Okay. What about this one? Ammonium. Ammonium is the wet diaper. So this was NH4. Okay. And nitrate, remember NO3, -1. So all nitrates are soluble, all ammoniums are soluble. Sodium acetate, sodiums are group 1, so all sodiums are soluble. Acetate is the grumpy lady. Acetate's a grumpy lady, so acetate, that's C2H3O2 -1. Sorry about that, acetate. Okay. So they're all soluble. You can't combine anything with anything that's not in the pool. They're all swimming in the pool. Therefore, there's no precipitates and nothing can be made from it. Okay. How about the last one? Copper 2 bromide. Okay, so you have copper 2 plus. Bromine, remember, is the little kids in the pool. The little kids on the edge of the pool. Those are all soluble with the exception of what? It would be, oh yeah, bromines. It would be silver, mercury, and lead, and copper is not one of those, so it's soluble. Ammonium is the wet diaper, NH4. Okay, it's soluble. Sulfides are usually not soluble, but ammonium is, so it makes it soluble. And this is 2 negative. Okay. So, well, what we got? Okay. If ammonium goes with bromine, okay, nothing happens because all ammoniums are soluble, and these are in the pool too, so no problem. What if the copper goes with the sulfide? Sulfurs are usually insoluble. Ammonium and group 1s are the exception. Copper is not an exception, so it's insoluble. It makes a precipitate. You end up with copper 2, so that's a positive 2. Sulfur is in group 6, so it's a negative 2. So it'd be CuS. Okay, lots of thinking here in these little boxes. You have to think very clearly to answer them right. So just keep working and I'll help you if I can.